Hi, this is from Dr. B. Vijay Kumar, HOD of Physics, Department of Physics, SNS College of Engineering. Today we discussed another one topic of crystal imperfection, point defect, line defect, Berger vector, stacking fault. So this topic is very important to the form of crystal physics because we discussed it only for the crystal structure, but we not discussed in the crystal imperfection and to the form of different types of defects wise. So this is a very most important topic of the crystal structure. First of all, what is a crystal imperfection? The crystal imperfection we call this a defect of the crystal. The defect in the irregular geometrical arrangement of the atom in a crystalline solid. A perfect crystal is an idealization. There is no such things in nature. Crystal defect we call this a point defect, linear defect, planar defect. The point defect, the place where an atom is missing or irregular placed in a lattice structure. The linear defect, which are group of atom in irregular position. Planar defect, which are interface between homogeneous region of the materials. So the classification of defect based on the dimensionally. Zero dimension, we call this a point defect. One dimensional, we call this a line defect. Two dimensional is a surface defect. Three dimensional is a volume defect. So zero dimension is a vacancy, impurity, Frankel defect, Schottky defect. One dimension is dislocation and discriminations. Two dimensional is a grain boundary, twin boundary, stacking fault. 3D is twin, precipitated, void, crack, porosity, and inclusions. The point defect or defect that occur only at a or around a single lattice point. They are not extended in a space in any dimension. These defects typically involve at most a few extra or missing atoms. Point defect include self-interactual atom, interactual impurity atom, substitutional atom, and vacancies. So this picture is clearly explained to the form of vacancy, self-interactual, substitutional foreign atom, interactual foreign atoms. So the interactional atom, the new atom is formed in between of the lattice formation. The substitutional is a bigger atom to form in. The vacancy, the one atom is missing. The Frankel pair, it's the atom is changed from that another one white space. The substitutional smaller atom is formed in that the atom positions. So this all is in a difference between Schottky defect and Frankel defect. So the Schottky defect is a mainly to form of the charge wise we discussed. So the Schottky is a form of charge the distribution is smooth. So the it's definitely to affect from in a the charge of the crystals. The Frankel defect is small charges will be interchanged from the inside of the crystal. It's not affected in a charges of the crystals. So this is a line defect. So the line, it's a form of defects deviation from ideal arrangement of entire rows of lattice points. Interatomic bonds sufficiently destroyed in a immediate vicinity of dislocation line. Dislocation affects the mechanical properties. The line defect that is produced due to the misalignment of atom in a crystal lattice. Line defect are produced two types of dislocation, edge dislocation, screw dislocation. So this picture is clearly explained to the form of edge and screw. So the extra row of atom it become missing of that, it's change in that atom positions and the slip plane is formed in screw dislocations. So the Berger vector is displacement vector that close the loop when transferring an equal number of lattice steps around the defect. So the atom it become missing to the form of the particular direction and magnitude. So that we call this in a Berger vector. The stacking fault, the shifter portion of the partial dislocation is a stacking fault. Atomic stacking order into the screen has changed was ABCA, BCA, BCA, BC. So the sequence become changed of that formations. So this is all the reference I prepared the PPT of the crystal imperfection, point defect, line defect, and Berger vector stacking fault. Thank you very much. We discussed in another one topic in another one video. Thank you very much.